Yes, does anyone remember? Okay. There's something called a four-fact family, and it goes like this. A plus B equals W. B plus A equals W. W minus A equals B. W minus B equals A. That's a four-fact family. If I know any one of these, I know the other three. You guys kind of with me? So those last two are kind of like the idea of a total. If I have a total and I subtract one chunk, I get the other chunk. So if A and B together make W, W minus one of them is the other one. You guys kind of, and of course the other one is just commutativity of addition. You guys? So if you see four-fact family in the homework, that's all they need. Is if you know one of those things, you know the other three automatically. Okay. Is that okay by itself? Is that okay? So I happen to give you like 8 base 13 plus what I can remember what I gave you. It almost didn't matter what I gave you. You just have to like, I could have given you letters and you would just have to move them around. Okay. Anything else from the quiz if it's still in your head? Okay, all right. So I'll have this graded for next time. Does everybody have this handout? Still, here, this guy. Does anyone need this guy here? Yeah. Bless you. So very quickly, if you didn't get this before, this is just an example of rewriting notes. Very quickly, how do you guys study for a class like this? Out of curiosity, how many of you guys take notes? Sometimes I'll be teaching and I'll look out and there's somebody just sitting there, nothing on their desk, they're staring at me. I'm like, you're amazing. Do you have photographic memory? What are you doing? Of course, I record my lectures, so maybe they go watch the video. You can even go to YouTube. You guys know there's like a YouTube transcript generator, so you can grab the URL of any YouTube video, search for YouTube transcript, whatever, and it'll give you a free transcript of from the video. You guys know that? And of course, it's automatically generated, which is a lot better than it used to be. I remember I used to watch my YouTube videos with my class just to see the subtitles, what it thought I was saying, because it was kind of fun. And of course, then I put myself on 0.25 speed. And, I sound drunk. You know, so, it's a lot of stuff. So this is me showing you, because when I was a student, the way that I studied was I reorganized my notes. Because sometimes you'd have notes from several days, but then this kind of goes with this. So I rewrite my notes, putting all the topics together that were similar, right? Complete geek here. Yes? This is me showing you like a notes rewrite example for 3132. Yes? There's a lot of ideas in this class. And it's really weird that they're related to things like subtraction and addition, but they're actually pretty meaty things related to those. So it's really, you gotta make sure you keep track of them. Okay, don't get too excited. I'm not gonna do this for you forever. This is one time. And then you can do whatever you want to with your notes. Okay. On the other side, I kind of don't, I was going to put you in groups, but I want to do this together because I have another group work thing I want to do later. I want to kind of save some time for that. Can you guys read through that first thing there on your own? The very first problem. Oh, sorry, do you want? Of course you do, because this is my last one here. So just, pretty sure I don't anymore. I don't know why I ran out, because I made more than I have students, but yeah, I'll give this, you can get this one, you're gonna be special. You'll get the one that I've written on. Yay! So you weren't here when I gave this one out? No, okay. Okay, does everybody see, I don't know, if you had just looked at this, how many of you guys would have thought that was the answer, potentially? How many of you guys have made that kind of mistake before? Okay. Does anyone see a way, a technique to keep from doing that mistake? Does it, besides, you know, what's a way I could do that just on my own?
20 first and then subtract 7.
Yeah. That's beautiful. So if I'm subtracting 27, that wants me to subtract 20 and 7, yes? You guys kind of with me? So 100 minus 20, we could all handle that shit. That's 100 minus 20. And then I'm gonna go 7 down from there, right? So that's beautiful. That's like the baseline, that's the thing you do to keep yourself straight. You guys with me? 100 minus 20 is 80. 100 minus 27 gotta be less than 80. There's no way the answer is 83, right? Okay. Does anyone else have a way you do that kind of problem? Yes?
I vote 1 less.
Kick ass. Oh my God, hold on. Sorry. I gotta celebrate when this comes up in the wild, because not everybody knows to do this. So explain to me again what you do exactly. So you start with 100 minus 27.
Yeah, and my brain will think, oh, 83, right? But I always go 1 below it. Even when like...
Wait, what do you mean by 1 below it?
1 below like...
1 below the tens place? Or how do you mean 1 below?
Like, yeah, the tens place. 1 below the tens place.
Oh, you shift it like that. Okay, that would work. That would be a general technique that would work. Okay. So here's something really cool. I can't remember if I said this to you guys before or not. What does subtraction mean? That's a small question. What's the meaning of life? No, what's subtraction mean? Yeah.
The opposite of addition is more.
Do it again.
The opposite of addition.
Sure. Take it away. Sure. How far apart are 10 and 6? What operation would get you there? Subtraction, right? So subtraction very, very fundamentally tells you how far apart two numbers are, correct? Do you all agree that 10 and 6 are the same distance apart as 9 and 5? If you and I are a certain distance apart, yes? If you scoot back one desk and I hop over this one, we're still the same distance apart, correct? So if I take one element in a subtraction problem and I shift it by something, as long as I shift the other one by the same thing, that's the same damn distance. Are you guys understand? What sucks about 100 is it involves borrowing twice. And that shit ain't easy to keep track of in your head, yes? So one kind of way you could do this is, if I shift this down by 1, that is closer to 27 than 100 is, correct? So then what do I have to do with 27 to keep the answer the same? 26. Now if I do 99 minus 26, okay. So there's a 70, yeah. Yes?
What do you think of also, like, adding 3 to the 27?
Yeah, okay, beautiful. It's almost like I planted you there. So the other way, just using the same principle, you can add 3 to this, then 103 minus 30 is like 100 minus 30 plus 3, so that's 73 still. So both of these use the same idea. If I have a subtraction problem, it's all about the distance between those two. So if I change where one thing is and change the other thing by the same amount, the distance stays the same. Do you guys get that idea? That's a really powerful, quick mental technique that you can use. That's a really simple, 10 minus 2 is 8, right? What do you want from us poor humans? So of course we're gonna make the 83 mistake, right? Okay. Number 2 is a little bit trippy. One thing that's trippy about number 2, what is it about, if you look through number 2, go ahead and look at number 2. Gaze upon number 2. So, what's the trippiest part about that? Anything. The fact that it exists, Jeff. I don't like how you indented that part. Anything. What's anything trippy, or are you guys completely cool with that? Shapes. Yes, shapes. We have achieved a triangle. Yes? Alright, you guys write down on the margin of your paper the plus sign. Just write a plus sign. Now below that, write a division symbol. Alright, so I want you to understand two things. Where'd those symbols come from? Did an alien race visit us and say, you will use these symbols to mean add and divide, or we will come back and we will obliterate you? Did that happen? Not that I know of, it wasn't written on the tablets.
The aliens came down today.
Oh shit. I guess maybe that's what's on the cave drawings. I don't know. Have you ever seen the astronaut looking guys on the cave drawings? No? On some cave drawings from thousands, millions of years ago, there's people that they're wearing space helmets. Yeah. That'll trip you out. Alright. My point is, the plus sign, and especially the frickin' division symbol, if you think about it for a minute, that shit's weird. Yes? If you really, really think about it, it looks like a tiny little Mayan number. Doesn't it look like blueberries and pancakes? Yeah. So what the shit? So, alright, I agree with you. The triangle's weird. It is just as weird as the division symbol. Why isn't the division symbol weird to us, though? Because we use it all the time. Is metric weird? Is metric weird to you guys? Can you show me what a decimeter is? Can you show me roughly what an inch is? In the air, can you do it? Anybody? Show me roughly what an inch is. Yes, everybody should be able to do it, right? Can you show me roughly, like I said, a decimeter? No, of course not, because we weren't brought up in it. Okay, I'll shut up, I'll stop. So, yes, I agree. That's weird, but it's just as weird as freaking plus. It's just as weird as freaking division. By the way, real quick, since I brought it up, does anyone know what the division symbol actually represents? Yeah, it's a number over a number. We just represent the number by a little dot. Math people were so creative.
Let's put dot.
Okay. So I have defined, and by the way, multiplication, we have to explain it to little humans. Addition, division's weird as shit. Isn't there a whole process behind that symbol? Are you guys understanding what I'm saying? I need you. When I say 7 divided by 8, that is trippy as shit. It's not even a full 1. You gotta do decimal. There's a whole process that goes into that symbol. Yes? So I've explained to you, if you see that symbol, it's not A plus B, it's not A divided by B, it's a triangle B. And that symbol means do this. Okay. So can anyone tell me where I left my glass? There. How do I tell if this is commutative? What would I do to check that? I've given you actually a great place to start. What does commutative mean? If it was commutative, then A triangle B would have to equal B triangle A. That's what commutative means, yes? You guys with me? So like multiplication is commutative because 4 times 3 equals 3 times 4. What problem did I already do for you? What did I already figure out for you? What problem did I do with the triangle? What would you do now to see if this might be commutative? What are you going to check 4 triangle 5 against? If it is commutative, what should 4 triangle 5 be equal to? 5 triangle. Okay, do it. Do 5 triangle 4. Do it. What'd you do today, honey? I did 5 triangle 4. Okay. Let's go. Do it. Do 5 triangle 4. Now we're going into this not knowing, right? So it could come out either way. I don't know. Actually, I do know. Did anyone get the answer? What'd you get? 6. So we got a 6. He could be right, he could be wrong. Anybody else get the answer? Anybody completely weirded out by what's happening right now? So we have a little, I've defined what triangle means. It just means take twice the first dude minus the second dude. That's not very hard math, right? So if I see 5 triangle 4, I'm going to take twice subtract 4. Twice 5 is, minus 4 is 6. So that dude is right. So is that the same thing as 4 triangle 5? What's 4 triangle 5? 3. And we just figured out that 5 triangle 4 is 6. Do I have to do anything else? Do I have to do any more work to answer the question if this is commutative? No, I don't. Why not? If it was commutative, what would those two have been? The freaking same. So I don't know if anybody out there is like worried, well, what about 3 and 7? Maybe 3 and 7 works. It doesn't matter if anything else works. It has to work always. If multiplication was commutative, oh, except 8 times 5. That doesn't, then no, it's not commutative. It's got to always work. Okay. Maybe? I don't know. Did the triangle really freak you out that much? I'm sorry. No? Associative. What do you guys think, now that you've seen this, what do you guys think about the possibility it's associative? Okay, so let me remind you. What does associative mean? Give me something with addition. Is addition associative? What does associative mean? What does associative mean? Yes, I like it. Somebody's like, okay. They didn't actually go, right. So it's when parentheses get up and move and it stays the same answer, right? So give me an example of associative using addition. Give me 3 numbers. 1, 3, 7. Is this the same thing as 1 plus 3 plus 7? Are those the same thing? Yes, and we already know that addition is associative, but that's how I can kind of get a feel if it looks like it is. And well, we already know it is. Yes? So how would you check out if a triangle is associative? Guys, what would you write to see if the triangle operation is associative? To see if addition is associative, I could write 1 plus, parentheses, 3 plus 7, and compare that to 1 plus 3, parentheses, plus 7, right? So what could you write to start checking out the triangle dude? Yes?
Could you do like 2 and then parentheses a?
Well, what's the what's the operation that we're using?
Almost position.
No. We're using triangle dude, yes?
Oh.
2, triangle dude.
A minus B, or in 6.
Keep going. I would do this. I would do 4 triangle 5, yeah? Because we already know what that is, yes? Now, I have to compare that to what? If this is true, I got to check to see if this is equal to what? What would I have to compare that to? 2 triangle, 4 triangle 5. To make sure if it looks like it's associated. So what would it look like now?
If you click the parentheses, there you go, yeah.
Alright, let me just, I like that. Grace is like, there you go, chef. Give you gold star. Good kid. Okay. 4 over 5 is off the point. So we already know what 4 triangle 5 is, right? What was 4 triangle 5? We already know what it is. What's 4 triangle 5? 3, because I already told you. Can you guys figure this out? Take a minute and figure this out, please. Here, now I'll help you out a little bit. I'll do this one. who's got that? Who's got 2 triangle 3? Yeah, what'd you get? 1? Yeah, okay. Because you twice the first dude minus the second dude, get 1. Over here I got here 2 triangle 4. Twice 2 minus 4 is 0. What's 0 triangle 5? How do you do the triangle operation? You take the first dude in you. You take the first dude in you. No, okay, so you've got the definition right there. Whatever the first dude is, what do I do to it? I double it, and then I subtract the second dude. So I double 0, minus 5, and what do I get? Negative 5. So it would so suck to try to prove associativity if it was associative, because that means I have to somehow prove it's always true. I just need one counterexample, and we found one, to show that it's not, it just has to not work once. Now, do you guys think that this pretty much almost always doesn't work? Yeah, I would say this is not going to work, right? There might be some numbers that kind of work out mathematically and make it work, but almost always this is not going to work. All we need, though, is one counterexample to show that it is not. Okay. And again, why did we do this triangle, dude? You all freaked out about the symbol, didn't you? You freaked out about the symbol of it. Yes? There was a time in your life when you had never seen a division symbol before, and the first time you saw it, well, the very first time you saw it, you might have been like, oh, yeah. But the first time you had to work with it, you're like, what? Right? You guys got with me? You didn't know enough cuss words to see, you're like, what? So, no. You guys got it. So, again, a lot of what we do is to further investigate the idea itself, which means I have to divorce it from plus, minus, times, divide, right? Just to get at the idea itself. And the fringe benefit is, you guys freak out about triangle the same way your student is going to freak out about freaking dividing. Times, it's the letter X. What the shit? Right? And then plus is just the times it kind of fell over. It's like, what the hell? Anyway, all right. Maybe you guys start to understand it. I mean, you know, like what's this symbol mean? Like when I say this, what's that? Yeah, you've internalized the question that asks, what does it take 2 of to multiply by this? Or what do you squared to get this? Yes? You've internalized the question. That symbol is weird as shit. That symbol's weird. What is that, really long leg? What the shit is that? All right. I'll stop. 4. Okay. All right. Oh, come back here. Now, this is like an addition or multiplication table, but it's actually an omega table. So omega is like triangle. It's an operation. Can anyone tell me well, I gave you an example already. You guys see how to read this? B omega C is D. You see that? B omega C is D. We've done addition tables. We've done multiplication tables. This thing works the exact same way. Yes? Can somebody tell me what C omega C is? C. Right? I'm going to assume you weren't saying yes in Spanish. You see. So I'm asking you now, is this commutative or associative or neither? How would you check to see if this is commutative? How can you check to see if this is commutative? Can you guys see anything that's kind of wrong in the table? Yes, Meg? Look diagonally. All right, so the more you do these kind of tables, the more you'll see. Do you see these two? Or even these two? Do you see how this is CB and this one is BC? If it was commutative, shouldn't those be the same? Yes? You guys kind of with me? Maybe. Okay. All right. That's fine. And associative, do something similar. What about number 4 here? Read through that. I'll go away from the omega, dude. Poor little guy. What does closed mean again? If you have a set and you operate on two elements of the set, the answer must also be so think of the set as this room. If you guys are all whole numbers, when I add two whole numbers together, is it in the room with us? Is the answer in the room with us? Yes, I don't have to go outside the room, so I can leave the door closed. I don't have to open it. That's what closed means. So a student says, if I have a set that's closed with respect to multiplication, which means if I multiply any two elements in it, the answer's in there. You with me? That's what that means. Then it has to also be closed with respect to addition. Is that necessarily true? What's the smallest set that's closed with respect to multiplication? And we're only working with whole numbers. 0. If I have a set that just has 0 in it, what's 0 times 0? 0. It's in the room, yes? Okay. What if I add a 1? Is it still closed? Is that closed with respect to multiplication? How do you check? How do you check to see if it's closed? You just check every multiplication you could do with the elements. What's 0 times 0? It's in there. What's 0 times 1? 0. It's in there. What's 1 times 1? It's in there. So is it closed? Every element, if you operate on another element with it or itself, it's still in the damn room. That's closed. Is that set closed with respect to addition? In fact, that was on the quiz, if I remember correctly. Is that closed with respect to addition? What's 0 plus 0? 0. What's 0 plus 1? 1. What's 1 plus 1? Is that in there? Do you have to go outside the room to go find 2? Maybe he's next door. Yeah, so you have to open the damn door, so it's not closed. Are you guys with me? So if I give you a set and I say, check to see if this is closed with multiplication. Here, can you guys tell me? So this is actually a counterexample to what they said. This is not closed with respect to addition. And okay. What about this set? Is this set closed with respect to multiplication? How would you check? What would you start to do to check if this is closed with respect to multiplication? Take any two. Give me two numbers that are in the set. 3 and 9. What's 3 times 9? Is it in there? Yeah. In fact, how did I build the set? Multiply by 3. So is that set closed with respect to multiplication? Yes. 0 times any of it is 0, it's in there. 1 times any of it is it, they're in there. And then 3 times anything is a multiple of 3, and I got all the multiples of 3, you guys. Is that closed with respect to addition? How would you show me? Pick two elements. 3 and 9, what's 3 plus 9? Is it in there? So it's not closed with respect to addition. You guys, is that closed making more sense? To check to see. Now some problems will be a little more than one step, but all you need in this case is a counterexample. Is that closed with respect to addition? Hell no. You can go even easier. 1 plus 3 is 4. 1 plus 1 is 2. Right? There's a whole bunch of shit that it's the addition answer is not in there. Okay. Alright. So what I want to do now, I want to talk about a couple things. We're going to talk about section 3.3, and then I'm going to let you guys work on a little handout. Some of you guys are going to be pineapples, some of you guys are going to be, oh, I got the axolotl, I have dinosaurs. We'll see what the hell I got, I don't know. If I write that, what does that mean? What is that? How do you read that? A is less than B, right? What's the first place that a student might naturally come across this idea in the wild? We've already discussed it. Toys, right? They're sitting next to somebody, they can immediately tell they have less toys than the other person. How do they tell physically they have less toys? than the other person.
They physically count.
So again,
They physically count.
they count them, but how do they tell that their count is less than that count? There's several ways, right? Yeah, so one really quick visual is if I wanted to make my pile of toys the same as this guy over here, this freaking, what the hell's up, why did you get 6 toys, I got 4? I realized how many toys would I need to become the same as what he's got? 2 in that case, right? So there is an immediate formal kind of way to interpret this. This is true, again like this, if and only if there is a whole number. You can do it, Jeff. N greater than 0, such that, oh boy, this is such great math speak. I love it. A is less than B is true. If and only if there's a whole number n greater than 0, such that A plus n equals B. Now that is a lot of jargon that just says if A needs something added to it to become B, then A is less than B. You guys see how that's what that says? I don't think I want to play poker with any of my classes this semester. You guys are like, don't give them anything. Do you guys understand what I mean? If you read that straight, you can get a lot lost in it. But that's all it's saying is, if I have to add something to A to make it the same as B, then of course A is less than B. That's all that says. If and only if means, if I had to add something to A to make it B, then A is less than B. And if A is less than B, then I have to add something to A to get it. It works both ways. That's what if and only if means. Okay. So watch this. Here's one thing we could do with this. There's a property called the transitive property. I sometimes affectionately call this the duh property, right? So this says that if A is less than B, does anyone think they've heard of this before, transitive property? Okay. You guys are like, you say all kinds of shit that I've heard of before. If A is less than B and B is less than C, then how do you think A relates to C?
It's less than C.
Huh?
It's less than C.
Yeah. Do you see why I sometimes call this affectionately the duh property? Right? Between you two, do you know which one, who's younger? You don't have to tell me your age, but who's younger? I'd love it if you guys are like, we born the same day, or you're just figuring out, okay, who's younger? You're younger? Okay, so you're younger than she is. You're younger than me, therefore you're younger than me. Yes? That's the transitive property. Do you see? It's really silly. On one level, it's like, yeah. Okay. Just to show you how this thing is used, if A is less than B, that means that B equals A plus N, yes? Like we just said earlier, are you guys with me? If A is less than B, then I have to add something to A to make it the same as B. If B is less than C, then how do I get C? I have to take B and add something to it, yes? Now look what I'm going to put. I can't put N because I don't know if it's the same thing they each need, yes? Okay, now watch this. What did I just say B equals? What did I just say B equals? So I can rewrite this as this. Yes? So this says C is A plus something. What's it mean if C is A plus something? That means that A, what did I just do? Oh, if A is less than B and B is less than C, then A is less than C. So if C is A plus something, A must be less than C. You're not going to have to do this proof yourself. It's a quick little proof. It's almost an unnecessary proof. We're like, we get it, Jeff. It only makes sense. But if A is less than B, I can write this. If B is less than C, I can write this. And what this means is C is A plus even more shit. You gotta add something to A to make it B, and then you have to add something on top of that to make it C. So of course A plus something is C. That means that A is less than C. Okay, I'll stop. Can you stop talking in riddles, Jeff? I'll do what I can. Okay, maybe. Okay. And then there's two little things here. If A is less than B, then what's true about A plus C and B plus C? What do you think? Which one's bigger? And this is all whole numbers, by the way.
B plus.
A, got it. C not equal to 0. So this still must be less than, yes. So if I have on the number line A and B, and then I move A up C, and I move B up C, then A plus C is still less than B plus C. I can't catch up to it if I add the same amount, correct? You guys kind of with me? It's kind of like if I'm born after you, I will always be older than you. You can't catch up to me by adding years, because I'm also adding years. Okay. I'm wanting somebody out there to go, why did you draw birds on that? Triangle dude and bird number lines, whatever. And then we have this. If A is less than B and C is not 0, actually it may be even better. C is greater than 0. What is AC and BC? So if I have A is less than B and I multiply both sides by a positive number, does the sign do something or does it still the same? So if I have 3 is less than 5 and then you double both numbers, the sign is going to stay the same direction, correct? Okay. You guys might remember something trippy happens with negatives, but we're not quite there yet. All right, we have done very little, right? I have kind of given you formal language for things I know you all know. So a concrete example would be 2 is less than 3. If I multiply both sides by 2, 4 is still less than 6. Yes? That's all that says. Okay. So here we go. Here comes the neat stuff. Okay. What do we know about exponents? Why were exponents invented? And you guys don't have to know this. But what's exponent mean? So if I put down 4 to the 5th power, what does that mean?
It's just another way to multiply 4 or 5 times.
Yes. So the drunk history of math is there was a guy who had to write 4 times 4 times 4 times 4 times. He had to do this 80 times. And he's like, screw this shit. I'm just going to tell people I have 80. You guys kind of with me? Whatever he's doing, he needed 80 of these. Based on the problem he was working on at the moment. He's like, holy shit, we haven't invented a way to... I just want to tell people I got 84s multiplied. Can somebody tell me what does this mean? 80 times 4? What does that literally mean? Because what's the most basic definition of multiplication? Repeated addition. So what does 80 times 4 mean? I have how many 4s adding? 80. So 4 plus, you guys with me? So on one level, some guy on the other side of the world doing 4 plus 4 is like, screw this shit. I'm just going to tell everybody that 80 in front of 4 means I have 84s adding. That is just a way to kind of write that quicker. Yes, a lot of mathematics is just you guys learning all the weird shit we do so that we can write things shorter. That's what a lot of math is. We made a lot of bad decisions, so it makes it even harder. So this guy is like, screw that guy, damn it. I was gonna do that shit. So then he's like, all right, are you guys at all with me? He doesn't want to write frickin' 84s. He just wants to tell people I have 84s multiplying. And this jackass said that means 84's adding. So he's like, you suck. What if I do this? What if I do like an 80 on top? That looks weird as shit. What if I do it on the bottom? That looks weird as shit. So then he said, I'll just put it there. Why not? You guys kind of with me? And again, this is one beautiful thing about this class. It allows me to fully talk about the fact that that was a choice we made. Exponents don't mean what they mean because they just do. We didn't find them on an ancient tablet and go, oh. No, we made that shit up. We completely made it up. It's useful, but it's made up shit. We could have put the 80 anywhere. And we would nowadays know exactly what the hell it means, right? All right, good. Every property of exponents comes from that decision. We made that decision, and then that propagated all these different properties. So what am I talking about? I don't know. I never know. Oh yeah. Properties. It become a thing. Okay. I'm going to use variables just to make this easier. Does anyone know what to do when you're multiplying like bases? What do you do with the powers? And why? Yeah, why? Why do we add? Why isn't that 14? Isn't 2 times 7 14? Now here's something trippy, you ready? You don't have to tell me, but somebody might have thought that should be 14. Let me say this. I'm going to say this. There is no 2. There is no 2. There is no 2 in that problem. There isn't. There's no 7. There is no 7 in the problem. What does x squared mean? Break it down. X squared means x times x. There's no 2 there. There are 2 x's. There's no 2. What does x to the 7th mean? So I got a chain of 2 x's times a chain of 7 x's. Of course the damn answer is x to the 9th. I'm just keeping track of how many x's, yes. And watch the analogy here. So the work is x times 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 x. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go, screw that shit. Let me just add the freaking powers. What is 2x plus 7x? Yes, because that means 9x is adding. So the power just keeps track of how many I'm multiplying. The coefficient, we keep track of how many I'm adding. That was based on the choice we made as to how to represent. Some dude said 7x means 7x is adding. So I add 2x's, that's 9x's I'm adding now. Same thing with multiplication. Same thing with exponents. Chapow! Okay. What about when I divide? What do I do? Subtract. Why? What does x to the 7th mean? Why did I pick 7? What does x to the 7th mean? X times x times x times x times x times x times... Oh, is that right? 1, 2, 3, 4, 5, 6, 7, 8. What does x squared mean? How many x's will cancel? 2. So then I'm left with 5. So we said screw that middle step. Now I see I'm just going to subtract. Of course I'm going to subtract. Because when I divide, I lose x's. I'm multiplying a bunch of x's. I divide a couple, I lose those. Of course I subtract. Okay. And then, what about this? What is x to the 0? Here, this needs more room. What is x to the 0? What the ever-loving shit is that? Does anyone remember that this is freaky even if you don't remember what it is? Or can you tell this is going to be, somehow this is a little weird? Because what's x squared mean? That means I have 2 x's multiplying. What's x to the 0 mean? I have no x's, right? So watch this, watch. Real quick. There's so many ways I can explain this. I'm going to try a different way, and then I'll go and try the way I always do. I want to try something different first. you all agree A is 1 times A? Is that cool? A squared, I would just take this and multiply by another A. Is that cool? You with me? Nothing ground shaking. You know, what's A cubed? I just multiply another A, yes? You with me? I could keep going this way forever. I won't. Because I'm boring enough already. So I won't go that way forever. What if I go back the other way? So this is A to the first is 1 times 1A. A squared is 1 times 2A's. A cubed is 1 times 3A. So what's A to the 0? It's 1 times... A to the first is 1 times 1A. A squared is 1 times 2A's. A cubed is 1 times 3A's. What's A to the 0? 1 times... A to the first is 1 times 1A. A to the second is 1 times 2A's. A to the third is 1 times 3A's. A to the 0 is 1 times 0 A's. So it's 1. What am I going to write here? Nothing. No A. So what's A to the 0? 1. I'm going to show you 2 other ways to look at it. Here's the way I always do it. Some of you guys might think this better. Let's see. What would I put on the bottom so that I get x to the 0 using the fact that when you divide like bases, you subtract? What would the bottom have to be to make the answer 0? Another x squared, because then 2 minus 2 is 0, yes? So when I divide, I subtract powers. 2 minus 2 is 0. But what is something divided by itself? I just put a very intriguing note. Almost always. Does that way make any more sense? I don't know. You look at that 2 different ways. 2 minus 2 is 0, or something divided by itself is 1. There's one time that something divided by itself is not 1. Yeah, what number always screws us up? Negatives are 0, 0 more often. All right, how are you guys doing? You guys doing all right? Does anyone remember this? Anything to the 0 power is 1? I'm sorry. I'm making some of you guys so sad. I'm sorry. I'll be all right. You guys are looking like just keep going. All right. Here's the third way to look at this. What do I do when I multiply like bases? What do I do with the powers? You add them. What's 0 plus 3? Was the only thing that you multiply by, and the answer is the same as it was. Right? We call it the identity because it keeps something's identity. What's the only number you can multiply by, and it won't change your original number? 1. So what does x to the 0 have to be then? Because when you multiply by it, this guy stayed the same. He's got to be frickin' 1. Because it's the only number that does that shit. Okay. So what is anything to the 0 power? 1. So why did I say almost always? Almost everything. Here's why. You ready? What did we just say anything to the 0 powers? We just said it's 1. What is 0 cubed? What is 0 cubed? 0 times 0 times 0. 0. What's 0 to the 4,000th power? 0. What's 0 to almost anything? So anything to the 0 is 1. 0 to the anything is 0. So 0 to the 0th power is both 0 and 1. What the shit? So 0 to the 0, we very rarely bring it up. But I just want to give you a full picture. 0 to the 0 is worse than undefined. It's called indeterminate. And that's all I'll say about it for the moment. This is the kind of thing, though, you have to understand. Because can you imagine you're teaching exponents and somebody in the back, little Billy's always got he says, gee, what if it was 0 to this? And you're up there like, what? Well, so you have to have something to tell them. You don't want to just tell them, please don't just say, you'll know someday. I mean, what the hell's that? Or let's not talk about that right now. That's horrible, right? You gotta be ready to give them something. Okay, maybe. Okay. Let me keep myself on track here. Yeah, we can do that. Yeah. So what about this here? Well, how could I? All right. What if I had x? How do I want to say this? X to the a times y to the a. I like that. That's funny. Real quick, how do let me see if you guys are cool with this. You guys know how to factor this? What can I take out? The a. Because what does a coefficient mean? What does 7x mean? It means 7x is doing what? What does a coefficient mean? It means, like 7x means 7x is doing what? What are they doing? What is 7 times 4? Can you explain that, why it's 28 using addition? 7 times 4 using addition would mean what? 7 4 is adding, yes? Okay. Coefficients are based on addition. Does that make sense? Because 7x means x plus x plus x. Good Lord, Jeff, you keep picking 7. What are exponents based on? What operation are exponents based on? What operation? Multiplication. Yes? So you see how you guys told me to take the a out because it was addition and that's a coefficient? Well, here I can take an a out because this is multiplication and that's an exponent. That would distribute back in. If you look at this side, for example, if I gave you 2x to the third power, what am I raising to the third power? 2 and x. So that would distribute. What's 2 cubed? 8. Same way as if I had this, why does that distribute? Because what are coefficients based on? Addition. What are exponents based on? Multiplication. Yes? That's why exponents work well with multiplication, coefficients work well with addition or subtraction. Maybe? No? Screw you, Jeff? You suck? Okay. And this sort of goes along with this. What about this? X squared cubed. So very quickly, tell me, if I said to you, don't do this, but write down what you would do. I want to know what 17 cubed is by hand. What would you write down to start working on that? I want to know what 17 cubed is. What would you write down to start working on that? 17 times 17 times 17. Okay, so what's x squared cubed? X squared. What do I have 3 of? X squared. So this is x squared times x squared times x squared. What do I do when I multiply like bases? What do I do with the powers? What's 2 plus 2 plus 2? So screw this step. 3 groups of 2x's, that's the definition of multiplication. 3 crates with 2 apples in each crate is freaking 3 times 2. 3 groups of 2x's is freaking 6x. Okay. Do you guys remember this? The exponents? You can tell it's really hard. X squared times x cubed, people tell me the answer is x to the 6th. That, they tell me the answer is x to the 5th, because our brains look at 2 and 3 and we just go with what we're thinking at the moment. You just gotta catch your brain and say, no, brain, stop. Did I forget anybody? No. No, I didn't. Sweet. Oh, okay. So real quick, what is x squared plus x squared? This always trips people way out. Just remind yourself.
2x.
Yeah, it's 2x squared. Because if somebody writes x to the fourth, I'm like, I don't see any x to the fourth, so how do you get an x to the fourth? I see 2x squared, Steph. There's the answer. Because what keeps track of additions, coefficients? What is the only time exponents will change then if I multiply? Because that's what exponents mean. So x squared plus x squared is 2x squared, whereas x squared times x squared is x to the fourth. Coefficients keep track of how much I'm adding. Exponents keep track of how much I'm multiplying. You get it? So what's x squared plus x cubed? The answer could be you can't do it. Can you add those? No, why not? They're not like terms. X cubed plus x cubed I can do, right? Well, what's x squared times x cubed? Good, yeah, good. Okay, so addition and subtraction needs perfectly like terms. Multiplication and division are not that strict. I'm going to bring that back when we do fractions, because all like denominators are like terms. You just make it like terms. So when do you need them? Adding, subtracting. You don't need them worth shit when you're multiplying and dividing, because multiplying and dividing is not as strict with like terms. I'll bring it back. Yeah, like don't bring up fractions. Let it come when it comes. Okay. So last topic, and then I want to get you guys working on this worksheet. Order operations. Have I talked about that yet? Much? I think maybe the first day we did it. Probably I can't remember. Does anyone know the order operation? The order. Wait, I need more of whatever this is. Whoa. Does anyone know their order operations? How do you know? What is it? Yeah, PEMDAS. What does that stand for? Parentheses, exponents, multiplication, blah, blah, blah. What's the saying? Please excuse my dumbass son. Yes. Or dear Aunt Sally. Or, I need you to really hear me. This is a class came up with this. My students came up with this. You with me? They said, please excuse my deficient algebra skills. Yes? So all that is just a way to memorize the order. Now what really, really sucks, what gets me really freaking pissed off, is if you write it like this, as a student, you'll think multiplication comes before division, which is not true. But I have seen teachers teach that bullshit. So real quick, 4 times 4 divided by 4 times 4. I will tell you this, the answer is not 1. Because multiplication, division, you do it as it comes. Can you guys, really quickly, how can you rewrite division? Couldn't you just put it like underneath, right? Like A divided by B is A over B, is that cool? What's the only number that would go underneath? What's the only number I'm dividing by? 4. I'm not dividing by 16, right? It doesn't say divided by 16, it says divided by 4 times 4. So if I rewrote this, this would be 4 times 4 divided by 4 times 4, yes? So the right way to do this is as it comes. What's 4 times 4? Divided by 4? Times 4? The answer is 16. Of course it's 16. There's no discussion to be had. So when I dare go on this stupid Facebook, I see somebody put, what's the answer? And everybody's arguing. I'm like, let me just go cry somewhere, because there's one answer for the damn thing. And to me, this anyway, I'll stop. I'm sorry. But I have seen teachers teach multiplication for division, and that is evil. They must stop teaching. Just stop. Go away. Get a different profession. That's like teaching somebody grammar wrong when you're teaching language. What are you doing to these kids? Because that's what PEMDAS is the grammar of math. You're all very excited. So the way to write it, I could have written this like this. This could be the way we did it. Which one of these is easier to say? This one. If you say this one, anybody try to say this one? Yeah. Bibsa. You sound drunk. Cop's gonna be like, you were doing what? Step up.
Fitness officer.
No, sure. Do you guys I need you to understand, multiplication and division. There is no division. There is no division. There's multiplying by the reciprocal. There is no subtraction. There's adding the inverse. So technically, multiplication and division are the same operation. So they whatever order they're in is how you do it. So the right way to write PEMDAS is that. That is the right way to write PEMDAS. You definitely do parentheses first, you definitely do exponents second, you do either one of these as they come, then you do either one of these as they come. Notice addition subtraction is at the ass end of PEMDAS. Sorry, I just want to put that in there. I like that. So, let's do one example. That's all we need. We don't need more. So the most common mistake I see on a problem like this is somebody immediately does 4 times 5 is 20. Can you all see why that's bullshit? What's the only number I'm dividing by the way that's written? It is not fair to take the 5 and shove it down there too. That's not, I call it not fair, because it's like division is taking stuff away from me. So it's not fair to divide it by 20 when it just says divide it by 5. So don't make that a 20, that doesn't make any sense. So how do I do this shit then? What do I do first? Parentheses. What's inside the parentheses? So what's this? I'm going to make a mistake. What mistake did I just make? I made a mistake. What's this operation here? And did I lose the multiplication? Does it still mean multiply? No. So this answer, whatever it is, I'm supposed to still multiply it by 2, correct? I can't lose that multiplication operation. But I see that kind of thing all the time. So parentheses mean do what's inside first, but they also mean multiplication, correct? Okay. Now what do I do? Let me ask you this. What's at the ass end of PEMDAS? Addition and subtraction. So what's the very last thing I'm going to do? It's the very last number I'm going to do something with. The 3. This says 3 plus, I don't know yet. So that 3 plus is just going to come for the ride. It's at the tail end of PEMDAS, so I'm going to do it last. And by the way, don't feel bad if you have trouble. I teach 281, Calculus 3, and I have students who have trouble with order operations. So I mean, if you have any trouble with this, don't feel bad. You're in good company. And plus, I don't think they're teaching it well anymore in lower grade. I don't know what's going on. So what is 2 times negative? Oh, sorry. This is last. This whole chunk, what's the operations in this whole chunk? What's the only operations in this whole chunk? Multiplication, division. So you do it as they come. 3 plus, what's 2 times negative 2? Negative 4. What's negative 4 divided by 4? Negative 1. What's negative 1 times 5? Negative 5. So what do I get? Negative 2. Now, of course, officially in the course, we don't know negative numbers. In the real world, we know freaking negative numbers, so I might give you some problems. I have negative answers, but in the book, they're going to stick with whole numbers. So let me give you this, and I'll finally shut up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 21. Okay. Oh, that's perfect. Okay. Oh. I like that some people actually makes things up a little bit. You could be nice, you could be actually not.
That's crazy.
What happened? You could call. Alright guys, we've done this enough times now, right? You guys know how this works?